Hey, welcome everyone. Looks like
Hello, hello.
we are live and looks like sound is good. And hey, Artem, say anything?
Hi, Alex. How are you?
Yeah, I see you are good. And
Hey, everybody.
now, just a second. So if you see us, if you hear us, please set the thumbs up in the YouTube chat. If there are any problems with video or audio, also let me know. Meanwhile, I want to switch to different microphone. So you will hear me better now. Yeah, that should be good. How it goes for us? Good evening. Good evening, everyone. Good evening for you if it's an evening for you, or maybe it's a morning for you, like for Artyom. It's morning for you, right? Or around
Yeah,
midday.
it's 10 a.m., 10 in the morning.
Good. Oh, 10 a.m. That's pretty early. I still cannot stop wonder. I totally understand the concept, Earth, sun. So it totally makes sense what is getting to evening in my part of the world, and it's still morning at your part of the world. But these concepts still surprises me. Cool. Yeah. This meeting recording is going to be available to you. The same link. Everything is good. And actually, let's start because we have a lot of things to cover today. So we really have to keep going. First things first. It's going to be Introduction to NoSQL with ApacheCassandra. And that is a very great topic because there are a lot of powerful and great databases in NoSQL world, but one of the most interesting from the performance and scalability point of view is definitely Apache Cassandra. So we will speak about what is it, how it works, and how do you build efficient application with NoSQL databases. I am developer advocate lead at DataStax. Name is Alex Volishnev, and I really love my job because it helps me to work with you on getting developer worlds better. Because many people using different databases, they follow this hammer problem. If you have a hammer, everything looks like nails to you. So, and if you if you know only how to use a relational database, then you will go and try to solve all of the problems with relational database. Now, my job to give you right tools for the job you are doing. And for some cases, it will be relational databases. But for some other NoSQL databases will be much better fit. So, and today we are with Artyom Chibatko. Artyom, could you please introduce yourself?
Hi, everyone. Yeah, I've been working with Cassandra since 2014, and I've been working with many other databases, pretty much tried all kinds of NoSQL, relational, data warehousing databases. So I have a lot of perspective on this topic. And I love Cassandra, I love ASTRA DB and ASTRA Streaming, Pulsar, and happy to be here, talk to you about them.
Great. So, and by the way, secret is what today we will talk a little bit about data modeling methodology for NoSQL databases for Apache Cassandra. And Artyom is an inventor, developer of this methodology. So you are learning from the very first hands. And Nightbot says what weather for Houston is pretty good, sunny, and temperature is pretty nice. So good for you, Artyom. My weather in my place is not as shiny, I would say. Okay, but actually there are much more people worked on this workshop, and some of them today are in the chat. So please, it's a live event exactly for you to be able to ask questions. So please ask questions. If you are not so lucky and you watch a recording, then still please ask questions in our Discord server. Speaking of the workshop and Discord, few places you need to know to get maximum out of this workshop. First of all, that is obviously a YouTube stream you are watching right now. That's youtube.com DataStax Then, if YouTube works not so well for you, we have a backup stream on Twitch. But on Twitch, we don't watch and don't answer comments. So you better ask your questions on the YouTube chat YouTube chat, or even better, join us at our Discord server where we can communicate even when workshop is done. So that is a better way to communicate with us. And to ask you some questions in the beginning, and then to play a game with the prizes from DataStax, we will use Menti.com. But I will explain that in a moment when we switch to the questions. So you will see it in practice. Now, for the hands-on part of the workshop, you will need GitHub. I hope most of you already have some. And you don't have to install anything because we work with Gitpod, and Gitpod is a cloud IDE with a Linux box attached, so you can run all the commands, build your application, connect it to the database, use it, work it, develop it, without installing anything on your laptop. And as the commands executed remotely on a remote server, you don't even need a very powerful laptop to run pretty big containers, pretty big commands. And as we speak about databases today, we will use DataStax AstraDB. AstraDB is basically a Cassandra as a service in a cloud. So to avoid installation and all the maintenance burden, we go with Astra. But all the commands we're executing is exactly the same. If you would go with your own locally installed Cassandra, that also will work. That's good for us as well. Important point, if you want to make your LinkedIn profile more shiny, then you can get a badge from us. How do you get the attendance badge? Story is very simple. You just, first of all, attend this workshop, right? You do the hands-on lab, and in the end, you submit your homework using the link, what is specified on our GitHub repository, or I believe some of our colleagues will paste this link in the chat later. And then after some time, please give us the time to review your submission. We will dispatch an Intro to Cassandra workshop badge for you to brag on LinkedIn, Facebook, or whatever you prefer. Now, Menti. We will need Menti 2 times during the workshop. First time now for the questions, and second time later for the quiz with prizes. So please don't close it. Keep it open in another tab. Easiest way to go to Menti is basically use your own mobile phone and open Menti on your mobile phone if you are watching us on a laptop or whatever computer you use, or maybe TV screen, I don't know. So let's wait a moment. Let me switch for a second. I will switch to proper screen. Start. Right. Now it's better and we can finally start. So, Menti is behaving today, sorry. Yes, good, Menti works. So how do you join Mentium? Very simple. You or go to menti.com and enter the code you see on the screen, 46483101. Oh, code is hidden a little bit behind Artyom, but I see Rex pasted it in the YouTube chat already. Thank you, man. Teamwork. Or just scan the QR code above me. And let's go. First thing, I want to ask, where are you from? We have very distributed team at DataStax here. So Artyom is in Houston, I'm in West Germany, and we have people in France, we have people in Asia, we have people in Italy, in South America, basically everywhere. So I see some people joining from India, and that's great. We always had a lot of friends from India. And United States, United States, United States. Okay, free United States and East and free India. That is an interesting balance. Finally, someone from France. I think it's Cedric, but maybe it's some of our attendees. Let's go. Have you been to any of our workshops before? Hey, ciao, Isaac. ¿Cómo estáis? No, most of you are newcomers, so great. We run workshops nearly every week. So subscribe to our workshops at datastacks.com/workshops. Maybe some of our colleagues will paste the link in the chat, please. And for those who was at our workshops before, welcome, friends. It's always good to see you again. Artem, do you remember what will be the next week topic? I don't remember what do we speak about next week.
Let me check quickly.
Thank you. And now finally, before we go to the slides, what's your experience with relational databases? So do you use it a lot, or maybe you're a student with not so much experience? It's all fine. Hey, so distribution is quite interesting. Okay, I mean, like, it's even, it's totally even. Okay, some people don't have experience with relational databases. I believe most of the students. So take a look. This workshop, we are going to speak about NoSQL, non-relational databases. So your experience with relational databases definitely could help, but it's not a requirement. So as long as you understand what is the database, you are good to go. And we have a couple of SQL masters, which is great. Thank you. Keep this window open. We will need it for the game in the end. Now, let's start then. Thank you for answering, and let's go. Why NoSQL? But I'm not going to answer a question, why would you use that? I'm going to answer question, first of all, why it exists at all. Why? What's wrong? Is there anything wrong with relational databases? What now we speak about NoSQL so often, or it may be nothing too bad with relational databases. You will see in a moment. So, historically, relational databases dominated the world of relational databases for dozens of years, literally for dozens of years. But then later, that was not so much a thing anymore, and people started to talk about and people started to use relational databases more and more. Why it happened? General story is requirements have changed, and that is pretty important to understand. Maybe you remember the time, maybe you don't if you are young, when we were using modems to make an in connection with internet service provider. So specifically, when you run a modem connection, your your landline phone was not available for your neighbors or for relatives to use because it was busy transferring your data and it was extremely slow. It doesn't work like that anymore, and the single mobile phone, what I have, has more firepower than many of the mainframes of those times united together were able to produce. So, requirements really changed, and the world changed in the way what we will need much more data, much faster than before, and in the very different kinds of data, what it was hard sometimes to fit into the requirements of traditional relational database. Relational databases designed to run on a single machine, and thus they have limited scalability. When you speak about relational database, you usually speak about at maximum some thousands of queries per second. It may be a little bit more if you work hard enough and if your operations team database administrators are good, but still we usually will be speaking about thousands of operations per second. How much NoSQL can handle, it depends on particular database. You will see soon. Now, second thing, relational databases are actually great. They were great, they still great, they will be in use, so no one is decommissioning relational databases. They are great because for small to medium data size projects, they can work very well for both online transaction processing and online analytical processing. They're versatile. You don't need to run multiple different database tools to have your data available for both your customers and for your analytics. What is OLTP processing? In database world, OLTP processing workloads mean it's customer facing. Basically, it's data storage for data, what is being dispatched to your customers. And if you are the customer, do you like an application what works slow? No, you don't. I don't either. So that means what requirements for online transaction processing workload databases? Very fast, very high, very big demand on the performance point of view. While analytical processing workloads are much more about working with the data, very complex, very advanced queries. Customers who bought something in this year from the automotive category and have bought something from the last year in a different category when the weather was rainy. Like very, very many joins and things like that. Often work with cold data as well. So OLAP analytical processing does not have such high requirements for performance and quick response because you know what? There's not customers paying you money, but your analytics getting salary in your company working with an analytical processing kind of data. And therefore, we can wait because we are paying them, right? And story is relational databases are somewhere in between. They kind of can be pretty fast answering to our customers. They kind of be pretty powerful, generating different reports to your analytics and marketing and sales teams and so on. But it all works well as long as the data of your project fits into a single server. As soon as you have more and more data, and that's what we see on the previous slide, inevitably, each company has more and more data at some point. With data, if you have to dispatch it quickly, you have it to be delivered to client very quickly because of OLTP requirements, very, very, very fast. And what happens in the end? Relational database do not work well on the high requirements for big data or for the data of a big volume. As long as you can find a server big enough to fit your data, that may be acceptable. But then you have too much data, that doesn't work so well. What does that mean for big companies like Apple, like Netflix, like Instagram, like Facebook? It means they're going to need something different than relational databases. Take a look. When we speak about NoSQL databases, many people start to think about document databases because there's basically one of the most used kinds of databases, what I use it in the world. If I ask you, what kind of NoSQL databases do you know? Most of you will answer Mongo. Mongo is a great database, but it's only one of the many. How many database engines exist in the world? What do you think? Please write on YouTube chat. How many database engines are present and known by humanity in the world? What do you think? 10, 20, 15? Maybe 5? Maybe 1? Maybe 100? One. No, Rex. Okay, that is a good answer for someone working at data stacks. I understand there is only one database, but actually, I believe we can do better. Try to guess how many databases we have. Artem, do you think we will make it to guess any kind of closer? 8. Okay, it's bigger. Thank you, Kumar. Thank you for us answering.
It
But
has,
really,
has to be has to be in hundreds, right?
the real answer is more than 300.
Okay.
So then people start to speak what, okay, no, 60, more than 300, really more than 300. So then people start to speak about what is a NoSQL. I always say what situation is a little bit more advanced than you may think. We needed purpose-built databases for more specialized tasks. And we have document databases. Yes, those are great, but also we have graph databases to work with graph data. We have key value databases when we store simple data, but we need it to be scalable and available. We use object storages, objects kind databases when we need just to store blobs. We use tabular databases or columnar databases. We use time series databases like Prometheus or OpenTSDB to work with time series driven data, or we have ledger databases when we work with the data what cannot be deleted under any circumstances because it's a requirement of the law what your data stays available for audit forever and ever and ever, and it technically cannot be deleted at all. So NoSQL World offers you much more than just Mongo or just Cassandra. It offers you a set of tools, and as a good engineer, you need to know in which situation which tool to use. We have a dedicated introduction to NoSQL World workshop, but today we will speak about Apache Cassandra, one of the most powerful solutions of the NoSQL world. What is Cassandra? Cassandra was created to answer a specific problem. In the year 2008, Facebook reached their first 100 million users. By now, in 2022, if you watch us in 2022, that's not so big. There are companies having much more customers. But Facebook were one of the first companies to reach such a number, maybe the very first one. And we were in a pretty bad situation, in the situation when you are looking for a tool, what doesn't exist. Take a look. They had users all around the world, on all of the continents, or almost all of the continents. Most of their customers were having fast internet connection already by that time. They were handling really a lot of the data, like really a lot. And meanwhile, they have had high availability and fast response requirements, very strict SLAs. Then they were looking for a database which will make a better answer to this kind of problems. And as I say, they didn't found because such a database was never needed before. And that led to a creation of Cassandra in Facebook in the year 2008. Apache Cassandra is one of the most well-known NoSQL databases. It's a distributed, decentralized OLTP database. It's distributed, so it's created by design to run on multiple machines at once. Of course, for your test environment, your development environment, you could use just a single node. But why should you, if you could have ASTRA? We will speak about later. That's decentralized, so it does not follow master-slave or how it's primary server, secondary server, or leader-follower architecture. It's peer-to-peer masterless architecture, and it was designed to be extremely fast on each continent, everywhere under huge pressure of very heavy data, a lot of data. Then Apache Cassandra. What is it now in year 2022? Apache Cassandra is used basically by most of the Forbes list companies. Our Apple scale, by now I believe they reached around 200,000 database servers running only Apache Cassandra with hundreds petabytes of data stored there. Hundreds petabytes. I don't speak about things like terabytes, gigabytes of data. No, petabytes. That's really a lot. And they have many millions operations per second over hundreds of clusters. But my favorite guides from Cassandra point of view on Netflix, they open much more information about how they use Cassandra. Apple keeps its secrets, right? But Netflix is more open, so we know more. They have hundreds of clusters keeping petabytes of data. They have dozens, thousands of database servers, Apache Cassandra only. They use different databases as well, but for them, Cassandra is #1 database. And their single most active cluster handles 30 million iterations per second. Such power is just impossible with relational database. And don't forget, their clusters are geographically distributed, active. Last year, we have had Cassandra Day India online. And one guy from Netflix, cloud database architect called Vinay Kumar Chella, was speaking there. If you are curious about how Netflix uses Cassandra, there is a link on the screen, dts6.io/Cassandra at Netflix. And that is a very interesting talk to see how do they use Cassandra at Netflix. So if you would like to work at Netflix, when learning Cassandra is definitely a smart move. So why companies pick Cassandra today? It's created to work with a big data. It created to have incredible read and write performance over multiple regions. Scale in under any circumstances, scale well for big data and just add more nodes. Have very high availability. It also has to be automated very well. So otherwise, to run hundreds clusters of thousands servers, you will need really huge team of operations people just maintaining it. So a lot of operations are executed by cluster itself. And geographical distribution, so multiple deployments running at once together. It's platform agnostic and vendor independent. So what does that mean? Oh, Netflix Cassandra link, please. Gentlemen, could please anyone send the link? It's dts6.io/Cassandra at Netflix. Um, so big data ready. Cassandra uses partitioning heavily. Partitioning means what we split data into chunks and each server responsible for some of those chunks. That means what if you get too much data or too many clients using this data, you can add more servers and then data being distributed over multiple new servers. And each server is responsible for smaller pieces of data, therefore receiving less pressure or having more disk space. So ability to handle big data is the essential feature of Cassandra. Then read-write performance. Cassandra is decentralized and you can communicate with every server, and each server is already powerful enough to dispatch your answers quickly, but being distributed over multiple data centers and keeping your data close to your customers helps you to distribute the workload. Scalability. Netflix, I love this company, so you can guess, as I mentioned that many times already, did a very interesting research. They scaled their test cluster from 48, I believe, servers, like a little bit less than 50, to almost 300 servers, measuring exactly scalability. If that grows as well, if the line is straight or performance will be downgrading, downscaling, and then like if there is an overhead to add new nodes. And the fun fact is, what basically that is a totally straight line, and you can go further. So that is interesting because there are many databases what claim they are scalable, but for real, for most of them, like really for most of the databases, it will be in the end like that. And more servers you add, that will give you very minor performance boost. But here we have add more nodes, get basically twice as much of the performance. Good. Now, highest possible availability. Replication, decentralization, and topology replacement, we discuss later, gives us some incredible features. Uh, First of all, we always have live replicas. Outage of a single server or even outage of a whole data center doesn't lead to your data unreachability. Then if you have decentralized if you have decentralized peer-to-peer architecture, there is no single point of failure, so you can easily get to your data. Even if anything happens with a single server, you can write your update to another server, and that's fine. And also drivers mostly were created by data stacks, by the way. Have very strong reconnection and retry mechanism. So that is a very powerful feature, very important feature of Apache Cassandra. Then we go self-healing and automation. That means what basically cluster executes a lot of operation, what for other databases, you as an administrator or developer will have to execute. Oh, thank you, Artyom. Artyom pasted the link to Netflix blog with this scalability research.
Welcome.
Okay, so operations for a huge cluster are hard. And a lot of those operations are executed by Cassandra, so you don't have to worry about many things what will require manual operations with some of relational databases, for example. And finally, Cassandra's trademark is multi-data center deployment, and all data centers are active. So for with some databases, traditionally you have active passive deployments. You can have multiple data centers, but some will be active and some will be passive. So you can read data there, but you cannot write. In Cassandra, each data center is active. Apache Cassandra is not bound to any platform. It's an open source project, what you can run basically everywhere. And moreover, your clusters can be multi-cloud or hybrid cloud. So different data centers of the same cluster will work together, although one is being deployed at Amazon Web Services, another on Google Cloud, and third in your own data center on premises. That's totally fine, and you can go with that if you head for a real uptime and you cannot afford any downtime. Finally, what I like, as I am a big open source fan, um, DataStax does a lot for Apache Cassandra. It's our number one thing, of course, but DataStax does not have Apache Cassandra because Apache Cassandra belongs to Apache Software Foundation. It is a non-profit open source community already familiar to you. Even if you never have heard about ASF, you definitely know their products. Kafka, Apache Kafka, Maven, Apache Maven, Hadoop, Apache Hadoop, and so on. So that is a totally great project what helps maintaining and developing open source everywhere and does that for dozens of years already. That is actually a pretty old logo because they're older than 20 years old by now already. Okay, so I actually suggest us first to walk a bit to the next slides, and then we will do lab. What do you think, Artem? Are you fine if we do workshop after the next slides?
Yes, indeed. We should
Good.
skip
I
that one.
think it will be better. Good. So let's take a look. What's important for us? Like Cassandra is an incredible database. And one thing important to understand, by the way, Cassandra is not an easy thing to do for you as a developer or administrator. It's advanced technology. It's not a bicycle. It's an airplane. But you know what? Airplane pilots get better paid than bicycle delivery people, right? So learning how Cassandra works and learning all of its features and buttons and knobs is not an easy thing, but it's very well paid after all. Yeah, yeah. So it is a powerful, but it's harder to learn. But if it's well paid in the end, I'm fine with that, right? Good. So Cassandra is very powerful, but how it works? First feature, all servers are created equal. And that means what Cassandra does not follow traditional architecture you see in relational database world, like leader server, follower server, not like that. This architecture has problems. You know, it's a single point of failure. It's hard to scale for writes. An application needs to know where to write. If you write to a follower server, your write will be not applied. You have to write to you have to write to leader server. Cassandra uses different architecture. Cassandra is peer-to-peer architecture, so each node is able to communicate with each node. Each node can accept any read and any write, even if this particular node processing your query does not store data you ask for. It will know which node is responsible, and it will redirect your query to a proper node, dispatching all proper actions. This approach gives no single point of failure. This approach scales well for both reads and writes because you can add more nodes or repartition data in the proper way, and your application can contact any node or any data center if required. Now, data is replicated. What does that mean? Replication factor means the amount of node used to store each partition. Partitions we will discuss in a moment, But for now, let's say what each row you insert into the table, it will be stored on multiple servers. Replication factor is defined per key space, and key space is a group of the tables. So when you create a key space, you say, I create key space population, and it will be replication strategy, network topology strategy, and it will have replication factor 3 for United States West 1 and replication factor 5 for Europe East 2. On this scenario, I may have multiple data centers, but I will store data of the key space population only on those two specified on the screen. For United States West 1, each row will be replicated 3 times, and for Europe East 2, each row will be replicated 5 times. Replication strategy is an important thing because basically very easy to remember. There are only 2 replication strategies. What is replication strategy, first of all? Replication strategy defines how those replicas will be distributed over the data center. And that is very important. What's the story? Story is simple. First of all, you need to have your replicas as far from each other as possible. Why? Long story short, if you keep, does that make any sense if you keep a backup of your information on the same disk where you have your primary data set? Of course not. You want to have backup data on any another different machine or different storage, right? Otherwise, this backup may disappear right with your laptop, for example. And that is the same with those replicas. For example, if you run your data on a normal data center, you want to have those replicas to have them on a different server racks. Servers located together in a single server rack, they tend to fail together. For example, if a power outage, power can disappear from the whole server rack because basically it uses the same power supply and power delivery line. And that is a problem. If all of your replicas were on the servers in a single line, now this data is not available. So replication strategy tries to put data as far away from each other as possible. For a data center, it will try to put data to different server racks. And if you use cloud deployment, if you use, for example, Amazon Web Services, it will try to put data into different availability zones. This way, so if a single availability zone outage, what happens from time to time, then at least your replicas will be available, what place it in another replication, what place it in different places, in different availability zones. Good. So replication factor 1 means what every partition is stored on a single node. Replication factor 2 means what each partition or each row, for now, let's say row, stored on two different nodes, and 3 obviously means what it will be stored on 3 different nodes or 3 different servers. Now we finally get to partitions. And replication, together with partition, is exactly what makes Cassandra such complex, such advanced, but also such powerful solution. Data is distributed into partitions. What does that mean? In Cassandra, we work with data in tables. Tables must be familiar to you if you have any understanding of relational databases, right? So tables are basically the same, but they work differently. Data in relational database, a single table will be stored on a single server, right? And it will be duplicated to follower servers, for example. In Cassandra, it works differently. Data is split into different partitions across different servers. So this way, we distribute, if we work with really big data, what will hard to fit into a single machine, we split it into chunks, and then we have it like that, spread it over different servers. When we partition our data, and for example, server on top is responsible only for United States, when question comes, how do we do routing? How do we know which server asked for which data when your application needs to read data for Los Angeles, for example? Answer is simple. It's easy to calculate because we know how exactly data is partitioned, and data is partitioned based on the partition key. Take a look at this slide. We have this field, country, as a designated partition key. That means what all the records we have in this table will be partitioned based on their country, and therefore New York and Los Angeles will go together into the same partition. And when, for example, Nuremberg and Berlin will go to the same partition, and the same for Toronto and Montreal, they go to Canada partition, and so on. That happens because we called country a partition key in this case. Then we create a table. As you see, Cassandra query language is very similar to SQL. Please do not make a mistake. They are not the same. They look similar, but at the moment you start to behave like, oh, I know SQL, so I know SQL, you go to a very wrong path, what can lead you to a problem. SQL looks like very the same, but it's not very the same. It's actually very different. So, Adefemi, I see the question. I will answer it in a moment. When we create a table, first of all, we have to specify key space it will belong to. And as you could guess, this table will share replication settings from the key space. Then we have to specify the name. We give some fields, text, integer, country, city, population, and we declare primary key. In relational database, you very often ask your database for an ID to generate. With Cassandra and any other distributed system, it doesn't work this way, because then all the servers have to agree on which ID is sequential next, like sequential IDs in Postgres. And then if you have 100 or 1,000 of servers, it's definitely going to take some time. With Cassandra, we work differently. We create keys, primary keys, on the application side. In this case, we designate country to be the partition key. First argument of the primary key is a partition key, and then country will be my partition, and therefore my data will be distributed like that, based on the country. How it works then altogether. So, partition key, we just created a partition key for this table to be country. How it works internally. That is a cool thing. Take a look. We have here Cassandra nodes data center of 4 servers. Why do we have exactly 4 servers? Because I was too lazy to add more circles on this slide. So that's why this data center have only 4 servers. So when we go for it, we have special partitioner, which is usually murmur-free hashing algorithm partitioner, converting each value it's get to the tokens. Yeah, that's interesting. For the question, is it similar to Elasticsearch? No, it's not. It has quite exactly opposite purpose. Maybe my colleagues will answer in the chat better to that. So each value we give to partitioner being converted to some token, to some integer. And we see what USA becomes number 59, and Canada becomes number 12, and Germany becomes number 45. And we see what now, and each server in our data center is responsible for so-called token range. Token range is basically a range of tokens, right? And we see what server A is responsible for tokens 1 to 25, server B responsible for tokens 26 to 50, and so on. And then you could guess what all the rows with token 59 will form a partition. 59, what will be stored on server C. And then Canada goes to server A, and then Germany goes to server B. And that is a very important thing to understand. Usually, those numbers does not look like 12 or 59 or 45. Those are huge numbers, very, very long one. I don't remember how big they could be, but they are really, really big. You can have billions and billions and billions of partitions. Maybe Artyom remembers, but yeah, those are really big numbers. And why is it happening? Why do we split data into chunks? It's happening because big data your company working with cannot fit to a single server. Splitting it into chunks, we can help spreading them over multiple servers, and that makes our life much easier when we really have a lot of data. Good. So I want to answer a question. Okay, no, first let me show how the token ranges recalculation work. So people say what Cassandra is a great database, perfect maybe database for scaling. That means having more computational power or more disk space, more volume. The story is when we have a 4-node data center, the token range overall, the global token range is split into 4 parts. Each part is going to be 25%. Then, if we are a company waiting for Black Friday or we are Netflix, we work at Netflix, and we are going to release last episode of the last series of a Game of Thrones, and everyone in the world is going to watch it. Then what happens when we need more firepower? We need more servers because currently our infrastructure would not cope with that. So that means we get a new server, launch Cassandra on it, and tell to this Cassandra instance, yeah, man, there is your cluster, please join it. This node, node A, B, C, D, E, node E joins the cluster and says, hello, everyone, I am new here. Please give me some job. Looking for a job. And then happens this token ranges recalculation. Before it was 25% of tokens approximately per node. Now we have approximately 20 tokens because some token ranges will go to the new server. And as a result, the new node join cluster, token ranges recalculated, new node receives data from the previous owners, and that happens totally automatically. If you ever, and all the operations are live, this operation is live, there are no downtime. If you have ever done sharding with any relational database, you must be crying right now. I was crying first time when I see how Cassandra is doing that because I did sharding for relational databases a couple of times. It was extremely painful process. With Cassandra, it was just a magic, like a real magic. It is a magic, but the magician is you. So you still need to learn how to do this magic, okay? But the operations are done by Cassandra. And the same story happens when Black Friday is gone or everyone has watched the last episode of Game of Thrones. Everyone is unhappy. No one is buying anything from us or no one is watching whatever we are showing. Then we want to downscale to avoid paying for the servers we don't need anymore. Therefore, we decommission a couple of servers. Give your Cassandra time to move the data because we are going to take down 2 servers. You tell to cluster, I'm going to take down those 2 guys. Then cluster again recalculates token ranges. Now each server will be responsible for approximately 33%. And after the data migration, you can take down those servers and no downtime. All scaling operations are live. Data is being available to your customers all the time, 100% of time. That's it. Now I want to answer questions, and let's take a look what's going on there.
Yes.
Do you want to answer a question?
No, go ahead. I can chime in, but I did look at the question, so.
Okay. So Adefemi asks, does this replication require new nodes to be added in the cluster, or we use already deployed nodes on over data partition? So each node, as you see already, each node is responsible for a range of partitions, and therefore adding any new partition, like creating new data, for example, for a totally new country. I don't know. Let's say we just got a new country somewhere in Antarctic. Then it will create a new partition, and this partition will have token, let's say, 78. But just because murmur-free hashing algorithm generates from our new country token 78. Then this token obviously goes to this server. So adding new partitions, they will be put on the servers what you already have. And only when you add more servers, you think like there's too much partitions on my servers. My servers are too busy, or I need more disk space. Then you go for scaling out, you add more servers, and data is being redistributed. So each server is responsible for less amount of partition. It has more disk space and answer less requests, so it can do it fast. Good question, thank you. Now, pum, pum, pum.
So the cluster will have certain number of nodes, and then when you create key space, you tell how many replicas you want to place of each partition. So if you have 10 nodes in the cluster and your replication factor is 3, you have enough nodes to have 3 replicas. So that's the and if you keep adding more nodes, you can increase replication factor if needed. Or if you even if you don't have enough nodes to create that many replicas, you still will be able to create key space. You will get a warning, but you will be able to create key space and add nodes later.
Yep. Now, the question from Surath regarding table with video files. A video file in this case is not being partitioned because data is partitioned based, that is a group of rows. And if video file in your example is not a row per se, but it is a column of a row, then obviously it will be not partitioned. If I got the question, maybe I didn't get the question. Now, are there no room for scale up as well for each node already generated? I mean, increase compute power. So, scaling up is a good question, but scaling up for a really big data becomes prohibitively expensive very soon. First, second, there are some limits. So when you scale out, you can add as many nodes as you want. Then you scale up, then at some point, every next server upgrade will going to cost you a real fortune, like real fortune. Then that's better instead of making servers scaling up. Start with some reasonable commodity server and just add more nodes. It works better. Second point, what I wanted to mention about scaling up, you definitely do not want to have servers of different computational power in your cluster because token ranges recalculation. Right now, your server A is most busy and you decide, okay, servers B, C, D will stay at the same level, but I will do hardware upgrade for server A. Sounds good? Doesn't work. I mean, it works in the beginning, but then token range recalculation, data is being moved into another node. Now server B is the most busy and server A is idling. And what are you going to do? Downgrade it again back? Our recommendation is do not try to better not have servers of different performance, servers of different type across your data center, but you really better have your servers of the same type and just add more if you have to scale. What decides which token should store in which node? So how token ranges are being calculated, that is a long story, but that's not so important for a developer as what you need to know is how do you design your partitions, and Artyom will explain that soon in his part. So soon we explain on how do you design that. Yeah, and thanks, Rex. That's really based on the consistent hashing algorithm. Okay, now finally, how it works together. We have partitioning and we have replication. So that is the secret sauce of Cassandra. Partitioning plus replication working together means what each server is technically responsible not only for its own token range, but also for token range of two other servers. Well, two other servers with replication factor 3. You may have different replication factor, but the general story is what each server is responsible for few different token ranges. And that is very important to understand. With replication factor 3, then data arrives to your cluster. It will be split into 3 different machines. What are responsible for token ranges where this data fits. Boom. And your data is partitioned. and replicated, so it's highly available. Each Cassandra node and even each Cassandra driver understands data allocation in a cluster. It's called a token aware. Your application can contact any server and still get the answer, even if the server is not responsible for this partition you are working with. But usually, as Cassandra drivers are also smart, they will contact not just some random node, but they will contact replica node for this partition because driver is also token aware and driver understands which server to work with for this insert or for this select. Very important point. What very common misconception, very common misunderstanding. When you launch an application, many people think what your IP addresses you give in the configuration are the IP addresses of the servers your application will be working with. It works like that in MySQL, but Cassandra is totally different. In the beginning, you give only initial contact points. Then your application starts, then Cassandra driver starts. It will use this IP address to reach out the cluster and tell, hi, I'm going to work with you. Could you please explain me who is responsible for what, how many servers in the cluster? Because driver is token aware. And then cluster explains what, you know what? That is server A, its responsibility token ranges this, and that. That is a server B, and so on. There is one disadvantage, obviously. Driver startup takes some seconds, takes a couple of seconds. But there is a huge advantage, obviously. Once application is running, all operations will be significantly faster because driver will contact directly the node it has to contact because it knows who is responsible for what. Finally, data is globally distributed. So that means, as mentioned already a couple of times today, you can have your data centers on multiple of the different cloud providers simultaneously working as a single cluster still, despite there being deployed one on Google, second on Amazon, third one on your own data center. And those data centers can be everywhere in the world. Now, I have to ask you a question. So please get ready to answer on the YouTube chat. It's not a quiz yet, so you will not get the prize. What is the biggest problem of replication? We need replication because it's the one and only way to have your data available even in case of a server outage, power outage, network outage. But by doing replication, we also create a problem for ourselves. There are multiple problems, but I'm curious if you could guess the biggest problem. Consistency. Hey, I see a man of a culture here as well. Right. So replication creates a problem of many network operations required more for them because now we have multiple servers storing this data. Then also disk space. Because replicated data, if you have replication factor 3, your data will consume 3 times more disk space than before. And that is a big problem, but you know what? Disk space is cheap, but reputation is priceless. So if you cannot afford to pay 2-3 times more for your disk drives, then most probably Cassandra is a wrong choice for you. But as we speak about usually Forbes level companies, those they can afford buying one more disk. It's totally fine. Or maybe dozen, hundreds, or thousands of new disks. Then performance. No, performance is not exactly the problem. I mean, that may require that create some more pressure on the servers, but it's not the biggest one. And yeah, biggest problem of the replication is potential inconsistency. So consistency is not the problem, consistency is concern, but I still count it as a correct answer. Then you write an update, so you change a price for an item in your store from $12 to $13, and one of the nodes may not get an update. And as a result, we have a situation when 2 nodes were updated and one was not. So, what does that mean for us? This situation may lead to very serious problems. As a business owner, you don't want to sell your goods with outdated prices. As a business customer, you don't want your bank to store your data in the inconsistent mode without like missing some operations, right? So, consistency is the biggest problem. Potential inconsistency is the biggest problem of replication. Obviously, that is about any any distributed replicated system. You introduce a cache layer in your application, you can run into exactly the same situation, even if it's not distributed, just the same server cache, just because you didn't invalidate your cache. And cache invalidation sometimes is a big pain, especially for distributed systems. So obviously, Cassandra developers took it very seriously from the very beginning. How Cassandra handles that? One of the first, there are multiple tools to handle this problem, but first layer I want to discuss today, one of my favorite ones, so-called hinted handoffs. When your application receives data, it will calculate which server is responsible for this partition. You have seen that already, and dispatch this data. Servers, what got this data, they will have to answer, okay, we got it, but one of the servers is down, or there is a network connectivity problem, and it cannot store this data, it doesn't get the update, and therefore does not confirm the receival of this information. Then this server who was coordinating this request, server coordinating a query is called a query coordinator. So query coordinator notices what it's something is wrong and one guy is not answering, and it will store so-called hinted handoff. Hinted handoff will be stored persistently on disk, and then the server is recovers. Hinted handoff will be delivered to it fully automatically, and then data is done. Data is consistency is recovered, but that's only one of multiple tools to control consistency in Cassandra. Ours are more for administration team. So as you are developers, we will not speak too much about that today. But that thing is very important to understand. Again, the part I love here as someone responsible for um, Cassandra cluster or for whatever SRE, site reliability engineering, what it happens automatically. In the morning, you can wake up, go to your monitoring, and see what one server was down during the night for whatever reason, but now it's up and consistency is restored automatically, and you don't have to do anything. That is totally done by the server. So, and that is, I guess, turn for my dear Artyom to tell us of some very important limitations and very important things to understand working with distributed application.
Okay, thank you, Alex. Do we want to? I think we should do the first lab.
Okay, let's do the first lab and then proceed with, or we can do first and second lab together, as you wish.
Yeah, well, I thought about it. That's also possible. I just want to make sure that our attendees have some practice.
Yeah, practice is important,
yeah,
right?
as soon as possible. So,
wait a moment. I have to switch to your screen, I guess.
yes, please.
Give me a moment. So I will switch to your screen. Yes, you should be good in a moment. Yes, so let's go for hands-on lab. And
the
boom.
first one
Yes,
is
you are live.
really, really simple. Yeah, the first one is very, very simple. And okay. So I posted in the chat. You can see the GitHub link. It will bring you to this page. And the first one is just simply let's create a database so that we can use it. So it takes a little bit time to create a database. The creation process takes a few minutes. So we will create it and then we'll go back and talk about CAP theorem. Many of you ask about consistency, availability, partition tolerance, and we're going to establish relationship between those three properties. But while we're doing that, our database will be created. So you can go to the create AstraDB, this link, and you will, if you already have an account, then you will sign in. If you don't have an account, you will sign up, and you can use your, for example, Google account to sign up, and you will get to a dashboard eventually. And what you will need to do is, so there are a couple of things depending on whether you participated in previous workshops or not, but we will create a database with name workshops and the key space with name sensor data. And we will use Google Cloud, and one of the regions I will show you will be available. Okay, so if you don't have, I already have workshops database here, but I will create a new key space. And if you don't have the workshop database, you can click on create database, and you can copy paste your workshops and sensor data here. Okay, copy paste or type them in, and sensor data. And here you will need to select Google Cloud because this is a free plan. So there are only regions available on Google Cloud. There is one in North America. You can select. The others are locked, so don't worry about that. You can also, if you're in Europe, you can select this region. In Belgium, in Asia, you can select India, region in India. And then you just click. So once you select, you have name of the database, name of the key space, click create database, and it will be created. So in my case, and it will take a little bit time for it to finish the creation. So in my case, I already have a database, and my computer is a little bit slow. That's because we're running all these videos. So I already have workshops database, so I will just select it and add key space, in this case, sensor data, and it will be created. Okay, and I even have the key space already, sensor data. Okay. So this is all you need to do in this first lab. Just create the database and key space sensor data. And
yeah, we do it a little bit in advance because creation of a data may take some seconds, so we better do it before we start working with data.
Yes, and then in the next lab, we'll create tables, and we'll insert some data, and we'll query that data. So let me know if you have any questions, or you're good and already done with these simple steps.
Process looks good to me, and I expect, yeah, if you are ready, please set the thumbs up in the YouTube chat. I will show you how. I will be the first one because my ASTRA is already running. If you prefer to run Cassandra locally, it's totally fine, but we don't want to make you deploy anything today, so we better stick to already deployed one by us.
Yes. So we can continue then, and we will talk about the CAP theorem. So the CAP theorem, CAP stands for consistency, availability, partition, tolerance. These are three properties, three features that this theorem basically states a relationship between them for distributed systems. So what are those features in more detail? Availability means that the distributed system will give you a response, which is not an error response. So it means, in other words, it's uptime. The system is not down. and it's going to give you some meaningful response rather than an error or timeout or something like that. So we usually want system to be available, otherwise our customer is not going to be happy, right? Because our website or our whatever transactional system is not available. That is a problem. Then the other property is consistency. It means no stale data. Remember we said that because we replicate data, the replication doesn't happen like momentarily. It takes a few milliseconds here, and maybe the other node is slower.
Yeah,
So
especially when you have multiple data centers around the world, there is still speed of light problem, you know?
yes, indeed. So in that case, consistency means that you get the most recent data. The data that you wrote the most recently, you will also read it. So you do not read the stale data. And if you read the stale data, so it basically the previous version of that data, that sometimes can be a problem, but sometimes it may not be such a big deal. And we will look at how we can tune consistency to make sure that we always get consistent data. And partition tolerance is ability of the distributed systems to survive node failure, just one node, multiple nodes, or maybe the whole network partition, like the whole data center is gone and you have the other data center. So what's going to happen in that case? So guess what? For the CAPS theorem, all the distributed systems will encounter some kind of failures. If you have a cluster, you have many nodes, so the probability that one of them is going to fail increases. So in this case, basically all distributed systems select partition tolerance as one of the features, but they cannot select all three. So the CAPS theorem states that you can only have two features, or the distributed system can be designed to guarantee only two of those properties. Partition tolerance is one, what most systems select.
Yeah,
And then you
you
have this.
definitely don't want to sacrifice partition tolerance. In no way. It's the most important part.
Yes. So if basically if you sacrifice partition tolerance, then you have you either working with a single node system, like a relational database. If something goes wrong, it's neither consistent nor available anymore. So we select partition tolerance, and then we select either consistency or availability. So some systems are called CP systems and other systems are called AP systems. So is Cassandra AP or CP? Cassandra can be both depending how you configure consistency, and each request in Cassandra can be executed with so-called consistency level. You can specify whether you want, for example, only one replica to return data for you, or you may want multiple replicas, majority of them, or you may even want all replicas to return you the data, and then you always get the most consistent data. So it's called configurably consistent or tunable consistency. That's the concept in Cassandra that allows you to basically change the consistency, basically to change the dial between consistency and availability. So make it so if you increase consistency requirement, then your availability decreases, right? If you okay with lower consistency requirements, and your availability increases, right? So if you have 3 replicas, one of them failed, you can still read data from 2. But what if that one that failed had the most recent data, right? So you have to kind of understand those concepts. So in Cassandra, every request, every read and write, insert, update, delete, select will have a consistency level that you can specify to execute that request.
Yeah, we show
So
it on the next slides in more details.
yes. So here we have the example of SQL shell command consistency, which gives you the current consistency level. And you can also set, so the current one was quorum. and then we set it to all. We change it to all. So we will talk about these different consistency levels. So there is any one, local one, two, three, quorum, local quorum, each quorum, and all. So so some of them are easy to answer. Like one means that only one replica needs to needs to respond to your request. So it needs to acknowledge read, it needs to acknowledge write, or it needs to return you data for the read request. And then 2 and 3, 2 replicas. Quorum is going to be majority replicas. We will see some examples shortly. Local quorum, it's a quorum for one data center which you connected to. So you have 3 data centers in this example. Local quorum, if you connect to this data center, to one of the nodes, it will be coordinator. Then local quorum is only concerned about the quorum with this data center, and it's not going to query, you're not going to access the other data sets. Each quorum means that each data center will have to respond, a quorum of replicas will have to respond. Okay, all means all nodes in the cluster, so literally all of these nodes will have to respond. Any is basically even any replica.
Any is the best choice for you if you like risk.
Yeah, so you cannot read with any, you can write with any. So when all replicas are done, and you can still write with any, and that's coordinator is basically gonna hold that data for you, will hold it, and then when replicas are up, it will distribute it. But again, any is nothing that you want to use. Okay, it
Yeah,
exists,
it's a
but
very special use case, not a general case like that for edge cases when you work with data what you can afford losing.
right. So in this example, we have 3 replicas, replication factor 3, and consistency level 1, and we are writing data. So in this case, what it means, since we have 3 replicas, we will write to all 3 of them. All 3 of them will get a copy of the same data. But we will, this node, which is coordinator, so it will initially, client connects to coordinator, and then based on consistency level 1 and replication factor of 3, this coordinator will know which nodes will need to store that data. It will send them write requests, but it will only wait for one response, one acknowledgement from one of the replicas. So because consistency level is set to 1. So maybe this node is the fastest to respond. Maybe it responds in 5 milliseconds, but the other one is responds in 7, the other one in 8 milliseconds. So it doesn't matter for the coordinator. As soon as coordinator gets the response from one of them, and it will get from others, but it doesn't care. As long as the one response is there, it will confirm the write to the client. Okay, so it happens very fast. In case of consistency level 1, and many use cases with large data sets, with large throughput, will just use consistency level 1 to speed up things. In case of consistency level quorum, we still have 3 replicas here that coordinator sends data to, but we need to get response from majority of them. So it will be 2 replicas. The first 2 that will respond the quickest, the coordinator will get the acknowledgement and will respond to the client that the request completed. And then the third will respond as well, but we don't care about his response anymore because we already got majority of responses. And then in case of consistency level 1, all replicas will have to get a response. Okay. But consistency level all is not a great consistency level to use, because what happens if one of these replicas is down, right? The request cannot be completed. So you basically you choose consistency completely over availability. If one of the replicas is done, you will not be able to complete the request. You will not be able to acknowledge it to the client. So consistency level all is not a good consistency level to use in practice. So and you usually don't need to use it because you have other ways to. So if you want to ensure that you always read the most consistent, most recent data, you can simply, the concept is called immediate consistency or strong consistency. You simply need to write with quorum and read with quorum, and then we will always get the most the most recent data that you wrote. So let's look at this example. This is our coordinator. If you're going to write into 3 replicas, 2 of them will acknowledge, and then we immediately, with second client, immediately we're gonna read with quorum, and we will read from only 2 of them because we don't need to contact all 3. We only need response from 2 of them. So this is the majority. Quorum is majority. So we will get response maybe from this node and from this node, and this node maybe it didn't acknowledge the write yet, but this node already has the data. It's the most recent one, so we will be able to the coordinator will be able to know which what is the most recent data, and it's decided based on timestamp internally. Okay, so you can, if you want to be safe, you want always consistent data, you just read and write at quorum. Okay? But if you want to be fast, then maybe you read and write at lower consistency levels, right? Like
It
1
very
or
depends. So the most important part here to remember is what consistency level is configurable per request, per each query you run. And the same application can work with different data. So for example, your application works with bank transfers and you want those to be like very, very consistent, right? But also your same application uses profile pictures for customers. No one will object if his profile picture will not be immediately updated on all of the servers at once. If some customers or some other customers will see a bit outdated profile pic. So this way you can go for faster than more consistent queries. So it all depends on the data you work with.
yes. So indeed, so you decide for your specific needs and requirements for your application. Okay, so the next topic, let's talk about a little bit more about tables and partitions. We already kind of discussed the how data is distributed, but let's take a closer look. So we have the simplest concept data structure there is called a cell. So cell stores a value, stores your data, and it belongs to, essentially it's a data in some row and some column. So the row is a basically consists of cells and its related data. In this case, we have a sensor network for forest. We have some sensor and we have value for that sensor. Okay, and those the sum of those rows that are related can be organized into partitions based on a partition key. So in this case, all rows that belong to the forest sensor network, they will be in the same partition. And we'll talk about how to organize them into the same partition. And now we also have columns, right? So the table consists of columns and rows can be organized into partitions. So basically, it's a partition table, partition and distributed table. So in this case, it's distributed based on the sensor network name, such as Volcana will end up on one node, which is different from C, different from Cry, different from Forest. But for example, ice and dog here, they will end up on the same node, and this is done automatically as long as we tell the system, we tell Cassandra what our partition key is. It's a network name. Then Cassandra is going to use Murmur3 partitioning to be able to decide which which token. So it will generate, will convert the that value to token, and will know exactly, the Cassandra will know exactly which node is responsible for the token range to store that token. So when we define our table, we give a name to the table. We also give column names and data types. But the probably most difficult part here is deciding on the primary key, because primary key consists of mandatory partition key, which can contain one or more columns, and optional clustering key. Okay, so in this case, we have clustering key, which is timestamp. But what is this partition key? So this partition key, it defines data distribution strategy. So given a sensor uh, and a date, all rows that have the same date and sensor will be stored in the same partition. What does it mean? They will end up on the same node. And when you retrieve that data, you will retrieve that data very efficiently, because it's called the concept of data locality. So the data is located on the same node. That node will read it quickly and give it back to you. And as we remember, there will be not just one node that contains a data, but possibly multiple nodes depending on the replication factor. So there can be 3 replicas that store the same partition. Okay. So here are some more examples. If we simply partition based on sensor here, based on sensor here, and based on sensor and timestamp. But these examples may not necessarily be the best, right? So at least some of them. The other concept, so the part of, so we said there is a partition key, sensor and data, there is clustering key, timestamp. What's the purpose of the clustering key? Clustering key uniquely identifies a row within a partition, and it also defines the sorting order within that partition. So the rows will be sorted either in descending or ascending order. You can specify here in clustering order by, based on that clustering column. So this first example where we have the sensor as a partition key for this table is not going to work, because basically we have many measurements, many temperatures will be measured by that sensor. There will be many rows for that sensor, but in this case, we have a partition key sensor, so there will be, for that sensor, there will be one partition, but we don't have identifier for the row. So essentially, each time we will override the temperature. So this is not a good design. This design is better because timestamps are unique. Our sensor takes measurement every second, for example, or every 100 milliseconds, something like that. So the timestamp will be unique. So we will have, in each sensor partition, we will have many rows. But there can be other things, like we will not be able to filter on dates. In this example, we want to retrieve all measurements from a sensor for a given date. So we are basically designing our partition key and clustering key for a specific query, and that's how data modeling is actually done. We will hopefully have time to talk about it in more detail. Another example here, the sensor value timestamp is not going to work for our purposes, because remember, the clustering key consists of value and timestamp. So it will be first sorted by value and then sorted by timestamp. So sorting by value doesn't make much sense in this example. And this is the one which will work. Sensor is going to be partition key, date, and timestamp clustering key. So sorting will be based on date and then based on timestamp. But timestamp is essentially so it does contain the date already. So it's a meaningful sorting. Okay, what's the difference between the last one and this one is basically date was part of partition key. Here it's part of clustering key, and that can be important because if your sensor takes measurements at a regular interval for a long extended period of time, you will end up with many values, many rows in this partition, right? Because Partition is uniquely identified by sensor, and every measurement will be stored in that partition. But here, the partition on each new day, new partition will be created for that sensor. So you can actually you will have multiple partitions here for this sensor. For months with 30 days, you will have 30 partitions for this sensor. For 30 days, you will still have one partition. So the partition size grows quickly. Okay.
Yep.
So, and finally, when you combine primary partition key with clustering key, you get the primary key, which uniquely identifies a row in a table. Again, to summarize, primary key uniquely identifies a row in a table. Partition key uniquely identifies a partition in a table, and it serves as a definition of how data will be partitioned, how this table will be partitioned. And clustering key uniquely identifies rows within the partition and defines ordering, sorting within a partition. Okay.
Yep. I wanted to say a word about this slide. Take a look. We discussed in the beginning what Cassandra, using Apache Cassandra in production is much more of like piloting an Airbus or a Boeing than driving a bicycle. And that is one of the reasons why. The story is, let's see how it works. Partition keys, you decide, then you create the table, will define data distribution in the table all around the cluster. Clustering columns, you define, then you create tables, define how data is physically stored, sorted on disk. Working with ApacheCassandra, we have to remember what we can speak about 1,000 servers with petabytes of data. So because of that, any change, could you please switch to the next slide? So any change of this kind of schema is not allowed. You can add some data column, so you can add more columns or drop some columns, but only so-called data columns. As long as column is mentioned in the primary key as a partition or as a clustering, you cannot change anything there totally, because changing partition key, adding some new parts, removing some parts would lead basically to reshuffling all data of a table in your cluster, and that is obviously a very bad idea. It will make your cluster busy for weeks while not being able to answer your customers' requests. And changing a clustering key is a very bad idea as well, because obviously it will lead to rewriting all data on disks, which is also not possible. So schema is immutable. If you do something, if your application changes, even if you did something perfect in the beginning, even if you did everything right, still your business may evolve over time, and that will need to some new requirements, some new queries, and all the things like that. So then you will need to create a new table and migrate your data. You cannot simply rework existing table. Add some data columns, remove some data columns, but you cannot change any parts of a primary key, and that is one of the big limitations. You need to remember. That's why data modeling is so important. We will speak about data modeling in the next slides, but in general, that is a very short introduction. If you want to be an airplane pilot who knows what he is doing and safely lands and takes off and lands with all the goods and airplane intact on the planet landing, not on disaster landing, you need to attend course on data modeling at the academy.datastacks.com, and great news, it is free. So yes, like we are a little bit crazy, we do great things for free. And that one is the most important part of your education as NoSQL practicing administrator or developer. Then you will get, when you will pass this course, you can become a certified administrator or Cassandra developer for free again, because DataStax sponsors your certification as well. If you will have any questions regarding that, I will drop a link in the chat. You can catch me on LinkedIn and ask me any questions. I will be happy to answer. Artem?
Yes, so it's important to get your primary key right. And if this is the first time you're hearing about partition key, clustering key, that may not be that easy, right? So you will need some time to play with them and see how they work. So this is your opportunity to actually create some tables, and we will be able to you will be able to play with Cassandra with tables, their schema, and we will also add some data as well. So again, you can go to the same. Okay, you can go to the same GitHub repo where there are instructions for you to create tables. Okay, let me log in again.
Yep. Regarding the hands-on lab Artyom is doing today, you can do it as a part of your homework if it's not convenient for you to do it right now, and submit it to us as a homework as explained in the GitHub repo or following this link. Homework.
Yes, so we can get started here. I will just guide you here in this. So you already have workshops database, and you have sensor data as a key space. So, and we will create table called networks. But first, we will need to connect to that key space. So I will copy this command, use sensor data. And you can go to CQL console. CQL stands for Cassandra Query Language. And you can do use sensor data, and you will be connected to this key space in CQL SH or CQL console. So the next command, we're going to create table networks. So looking at this table, we don't have clustering key, we only have partition key, which is a name of the network. So what it means is there will be only one row per partition. We cannot have multiple rows because we don't have the clustering key here. Okay. So the next one, we can do the describe tables, and we will essentially we will just get the names of the table like this example network. So we will skip this. We'll create two more tables, sensors by network. This one has network as partition key and sensor as a clustering count. So if you want to efficiently retrieve all sensors in a network, we need to specify network name, and we will retrieve one partition with all the rows representing, each one representing a different sensor. And then there is another example, temperatures by sensor bed, and we have sensor as a partition key, timestamp as a clustering column. And here, why is it bad? So it's explained later, but essentially we talked about it already. So if our sensor keeps getting new measurements, new values, then we keep inserting rows into the same partition, and our partition will grow uncontrollably. So we will have an issue at some point. We don't want to have more than 100,000 rows in that partition. We will create this table anyway, just for the sake of the example, and then we will make corrections. Okay, so we will drop this table now, and we'll recreate it. So, we'll recreate it the same columns, but the partition key design is different. Sensor and date now become partition key, and that helps to manage the size of the partition. Essentially, we split in the previous partition, which was just identified by sensor. We split in it for each date. We will have a different partition for that sensor created. Okay, so we drop in the table, creating the new one. What else will we need to do here? Just describe tables, and we will get the information, the describe specific table or describe all tables. Okay, but pretty much we created all these tables, and we got this message that client request timeout. Let's describe tables and see if the table was deleted, if it still exists or not. Okay, so it was deleted. Even so, there was a timeout. Essentially, our client didn't get the response on time, but we don't have this temperatures by sensor bed was deleted. Okay, and that's it for this exercise. So we can continue with the next topic. Let me know in chat if you
There were a question I wanted to answer.
Yes.
So I will switch back to my screen for a second.
Okay.
Of course. Display, right. Okay. So question was asked by, I forgot the name, sorry. Ravi Sharma. Yes, Ravi. Good. So replication factor 3, one node is down, one node is inconsistent. How do I get not stale data? How do I get consistent answer? You can see my screen. Yeah, you see my screen, right? Long story short, you have two levers, two knobs to control consistency. One is replication factor, which is defined when you create a key space, so usually a long time ago. And second lever, second button is consistency level, what you can decide to use per request. You have replication factor 3, and of those 3 replica servers, one is down and one is inconsistent. How do you get up-to-date information? Let's take a look at the list of consistency levels. If you go with consistency level 1, there is a 50-50 chance to get most up-to-date or stale data, because your query can hit updated server or it can hit not updated server. And therefore, you are in trouble because with 50% chance you can get outdated information. But that's exactly why consistency level 1 is not really recommended. It's recommended for some special use cases. If you want to have consistent data, you can go with consistency level quorum. Quorum for replication factor 3 majority means 2, right? That means what running a query coordinator will always wait for 2 answers, compare them, and if they are matching, it will return this value to you. As in this case, we wait for 2 answers, and we have one answer consistent, second inconsistent. Query coordinator will compare the data, what was written last, so what's the most recent value, return this value to you, to the client, so client always gets most recent value, and initiate a repair telling to the outdated node, Hey, there were some updates you missed. Please execute repair on this partition. Repair is a special mechanism what Cassandra does internally to recover consistency if inconsistency was noticed. There are two kinds of repair. One repair is initiated on read, what we just discussed, and second repair is what your database administrator or system administrator schedules for a Cassandra cluster, and that is very important to have running repairs on a regular basis. About repairs, we explain all in the Apache Cassandra maintenance and operations course, DS210 at the academy.datastacks.com, mentioned already. So if you read with quorum, there is no mathematical situation where you can run into inconsistency because you will always wait for a majority to answer. The only possibility to run into inconsistency with consistency level quorum if you wrote data with consistency level 1. If you write your data with consistency level 1, two servers were missing, the two servers were down, now they are available. You are making a query at the quorum level. By coincidence, those two servers with not most up-to-date value response first, and then your customer get outdated information. And that's exactly why we do not recommend to use consistency level 1, because it can be dangerous. So for most of the cases, read quorum, write quorum is the best recommended way to communicate with replicated distributed data.
Well, I would also add, well, consistency level, I believe the Netflix actually uses, in their blog, they use consistency level 1 or local 1, something like that. But
it depends on the data.
Yeah, it depends on the data. So I would not say we do not recommend. It just depends on how important it will be to read the most recent data. So for example, if you for example, recording user interaction with website, you probably don't care about quorum. You just write and read with consistency level 1. Another note for quorum, think about if you have globally distributed database and application, and you have data center in Asia and data center in United States. So there is a distance, right? If you say in quorum, then you are doing quorum across all the replicas across both data centers. So in that case, you need to think about local quorum and local one. Well, but for the sake of the example, local quorum, what it means. So if I'm in United States, I will be always connecting to my local data center. I don't need to connect to a data center in Asia because it's going to be slower. So I will be using local quorum and I will still get my data always consistent, right? If I'm using local quorum for reads and local quorum for writes. But there is a chance that the data is replicated to Asia data center, it will take a little bit longer time. So if you try to read from their data center, you may still get inconsistency. But you kind of think about those types of situations as well. So because you also want performance, right? Performance and availability. Availability in this case, if data center in Asia is down, I still want to be able to work with my data center in the United States. So the customers in the United States will not be affected. Anyway, we can
there is an
continue.
additional question. What happens if we got data from two consistent nodes? If you got data from two consistent nodes, then data will be matching. It will be the same data if they both are consistent.
There will be no need to resolve, right? The consistency. And the resolution is done based on timestamp. Each value that you insert into Cassandra will have a timestamp. It's stored there automatically. You can access it if you want to, but it's used for the resolving the inconsistencies in data.
Yep. So let's go further. Should I switch to your screen or will I stay with mine for the first couple of slides? I would like to switch you for art of data modeling, obviously.
Okay, yes, please.
Yeah, so I will say a couple of words about, okay, Yeah, right. So we better switch to your screen, right?
Okay.
Give me a moment. Right. So you should be, I think it's your screen
Yes.
live.
So we're gonna just in general touch data modeling. We will not be able to cover it in detail, obviously, but if you're familiar with databases, most likely you used relational database before, or you heard about it, and relational data modeling is different than the data modeling for Cassandra. So relational databases usually designed based on the requirements of what the whole enterprise, what kind of data the whole enterprise needs to store. So that data requirements are collected, analyzed, and then they modeled using well-defined relational data model, normalization theory, algorithms that allow you to decompose those relations into better relations, which I insert normal form or some other forms. Um, so and then only then you design an application, and usually it's not one application, your data for the whole enterprise. So you will have different types of applications that you design, and you just use those models. So when you design models, data models, right, when you structure, organize your data, you do not take into account applications, you do not take into account performance. You only start looking at performance when you need to optimize certain queries and you creating indexes there. But potentially for relational database, your queries will have joins. Joins are expensive, right? So you will optimize them, you will create some indexes, and you will have index-based joins and things like that. But they are still can be expensive if we're talking about really large data sets. So another way to think about this whole approach is relational database is called, usually it's integration database. It stores data from the whole enterprise, and then applications simply use that data. For Cassandra and most NoSQL databases, actually the approach is different, because NoSQL databases are application databases. They're not integration databases. They do not, the goal is not to store all data for the enterprise to reflect the real state of the enterprise. The goal is to support one particular application. So you start with application. You think about how that application, what type of data you will retrieve in one task, what type of data you will retrieve in the next screen, right? What data you will be available at this step, you will have available at this step, and what kind of queries you will execute next, and so on. And then you design, based on that knowledge, you will be able to design uh, tables that are specifically support those queries. So you design tables to support queries. So what I showed you previously, the table with partition key, with classing key, it's not very meaningful unless you know what type of query it needs to support. It was designed for specific query. Okay, so you design the models like that, and then you basically add data to your application generates data. You will bulk load some data, and you need to make sure that your queries are efficient, and they will be efficient. Sometimes we call this process denormalization. So we essentially we store data that will be retrieved by a query together, collocated. So we store it in the same partition. So another way to think about it is nesting data into partition. Document databases say they embed multiple entities, multiple data entities into the same document, and so on. But yeah, if you want to learn about data modeling more, Alex already mentioned we have Academy. DataStax Academy, and we have the whole methodology described for you. So there are essentially 4 models that you will work with. The first model allows you to understand the data, and this is called conceptual data model. It's actually independent of database. It can be used for relational database, can be used for NoSQL database, and we use ER diagrams, anti-relationship diagrams to work with them. You will learn about application workflow model, which is essentially allows you to identify the queries or data access patterns. So data access patterns are more than just queries, can be inserts, deletes, can be like transactions with multiple statements and things like that, right? And they are not randomly executed. They are executed by your application in certain order, because you have to log in first. You have to show the main screen, then you go to and to the next screen, and so on. And then we explain how to map those two into logical data model, which is based on query-driven design. So you design your tables based on queries, query-first approach, and we visualize it with so-called Chebotko diagrams. And finally, there is another step, optimization step, where we now start to worry about size of the partition, whether we need to split the partition or not, what kind of data types we will use. For example, we will use int, or will we use UUID or time UUID. So there are quite a few things there. But to give you an idea, this is a very small conceptual data model which says that the user can comment on many videos, and video is commented on by many users. So many users may leave comments for the video. So we have entity types, user, video, we have relationship type, comments on, and we have these attribute types, ID, email, and so on. And those that are underlined, they uniquely identify their keys. User has ID that uniquely identifies, video has ID. Okay, and when we analyze our application, we know that a user will open a profile. This is one thing. What do we need? What kind of query do we need to support for that? Maybe we need to find comments related to target user using its identifier and get the most recent first. So we are gonna do the ordering as well. And the other query, maybe when the user opens video page, we will find comments related to that specific video, so the user can read them, and they also will be ordered based on timestamp. So these are 2 queries, and they will deserve separate. Even so, in both cases, we'll store comments. We will organize them either by user or by video. So here is an example of these 2 tables. In the first one, comments by user, we may decide that the user ID will be a partition key. So this is a notation that we use to visualize those tables. And then creation date and comment ID will be clustering columns. And they will also be ordered in descending order or ascending order. And comments by video table will have video ID as a partition key. So essentially, if we want to retrieve all comments for video, all we need is to specify video ID and retrieve the whole partition with all these rows in this partition. And they will also be ordered based on the creation date for that comment. And then we can optimize. So what kind of optimization? So this is physical data model now, where we specified data types, UID, time UID, another UID, and text. And you can see we no longer have creation date, because time UID is a special type of UID which also has time component in it. So when we create comment, when the user creates comments, the comment ID is generated as a time UID, and we can always extract that time component, and Cassandra will actually use that time component to do the ordering for us. So we saved on one column right there. So here is how those tables can be specified in SQL, and they should be familiar for you already. So this is partition key, user ID, comment ID is a clustering key, and we specified how to sort it, and so on. And I think we don't have time to do the next lab, but you can probably do it as a homework.
Yeah, it's a part of a homework anyway, so please do it. Good, great. So I will switch back to my screen. Thank you so much.
Thank you, Alex.
My pleasure. And this one. Okay. So one thing I wanted to add regarding the data modeling. As you see, this is approach with denormalization, and for a long time we were taught what denormalization is bad and normalization is only way to work with a database. That sounds great at a university course, but when you hit real life, or better to say real life hits you with real life requirements, you run into the very soon run into the situation what even with relational database you have to denormalize, because denormalization means faster answers. And here, with non-relational database with no possibility to use joins, obviously we are going to use denormalization, and it is totally fine. The only thing you better you better understand what you are doing. You better be careful with that. Denormalization is good, then you control denormalization. And denormalization is totally bad, then denormalization controls you. So we have to pay attention. Yesterday I was at Mongo conference in Frankfurt, and we were talking a lot also about data modeling. We met an instructor regarding data modeling class from Mongo, and we were crying on each other's shoulders, like people don't pay enough attention to data modeling for NoSQL databases, and then they run into troubles, and we are trying to stop it. But they not always can stop it, and then they are doing some stupid things on production, and everyone is unhappy, and that is bad. So different databases, but still the same approach. Think of the workloads, think of a query. So you are going to run, how your customer is going to run this query, and design by query approach, and denormalization is good.
Absolutely. This is one of the optimization techniques that is used by relational databases, for OLTP databases, but it's very common optimization techniques used by OLAP databases, by data warehouses, because storing larger data sets is cheap, but doing the joins computation is much more expensive.
Yeah. And then you are going to create a report, and creation of this report takes hours, because you have a lot of data and a dozen of joins to execute over this data. And you cannot do them at once because they simply don't fit in the memory of a machine. So you have to do it group by group. That's fine for OLAP workloads, but definitely not fine. Even for OLAP, it's too much. But for OLTP, that's completely unacceptable. So denormalization is the only answer. Good. So you know what? There are a couple of dozens of people who stayed with us till the end, and I believe they deserve some prizes. They totally deserve some prizes. What do you think?
Absolutely. What
So
prizes
let's
do we
start.
have?
Yep. We have, I don't remember what do we have for today. I believe those are Cassandra t-shirts, maybe some more. I don't remember what we have today, but go on. If you are on Menti already, then good for you. If you are not on Menti yet, then please jump in right now, because we are starting in a minute. And Kumar, Winston, thank you so much for your warm words. Winston, it's a bit sad what you cannot join quiz. So please join us next week to take your chances to win our prizes. Let's go. Then it is the quiz time for Intro to Apache Cassandra. And we will start. Okay, we have enough players. That is great. A couple of more people to join. Okay, let's go. It's quite late for many of you, so I don't want to make you wait anymore. So answer fast to get more points. How many master nodes does Cassandra cluster need? At least 3 per cluster, 3 per data center, enough to maintain consistency. Not a single one, Cassandra is decentralized. Other family, I'm sending the link in the YouTube chats. Isaac too as well. Yeah, thank you, Aaron. So time is up. And right answer, Cassandra does not have any master nodes. And if you don't have any master nodes, therefore you cannot require some of them to be present. Not a single one, Cassandra is decentralized. Concept of a master node does not exist. Right answer is not a single one. Good. So let's go on. Show me the leaderboard. Try to catch up. So I see some people are only joining. Try to catch up. Kevin was the fastest one, and that was the right answer. Also, Tabiso, Suraf, and Ravi gave the right answers, but a little bit slower. So question number 2, and answer fast to get more points. How data is being distributed in a cluster? All data is replicated to each server. Data is distributed by partitions, range of partitions per node. Data is distributed with address locators. Data is distributed using postmail. That would be interesting to see. And I see 9 people are giving answers right now, and most of you made it. No, all data is not replicated to each server. Skipping big data on each server will basically ruin your business. That's for sure. It will be too expensive. So no, data is distributed by partitions. Now it was better, so many people made the right answers. Who was the fastest this time? Was it Kevin again? Hey, Kevin is fastest again. Good job, man. So, question number 3. Let's go. Answer fast to get more points. Which replication factor is recommended? 1.5, 3, 15, 42. I would really love to see replication factor 1.5 in action. That may be interesting topic. Yeah, Tom, what do you think? Right. Recommended replication factor is 3, and 1.5 is it's something really weird. I hardly can imagine that. Who was the fastest this time? Let me guess, Kevin? No? Someone to overtake him? Stop the Kevin! No, Kevin is fastest again, but this time Suraf answered in exactly the same time. Now Ravi Sharma is on the 4th place, and Suraf, Tabisa, and Kevin are on the first 3 places. First 3 places getting the prize. So, question number 4. Answer fast to get more points. What is AstraDB? What is AstraDB? We use it today. It's a gateway to the stars. It's a local and memory version of Cassandra. It's a Cassandra as a service in the cloud. It is a development tool. What is AstraDB? And time is up, and most of you made the right answer. Technically, Astra can be used as a development tool, of course. I mean, it's a part of the development environment for you, but technically, Astra is a Cassandra service in the cloud. Right. So, most of you made it, but who was the fastest? Let me guess, I maybe know the name. Who has the fastest internet connection and fastest fingers on the Wild West? Was it Kevin? Okay, okay. Not a big surprise. Kevin is fastest, and Tabiso and Suraf are keeping 2nd and 3rd place with Ravi Sharma trying to get even to the top 3, but it's not going easy this time. We still have some questions, and that's going to be question number 5 out of 8. So answer fast to get more points. What is a primary key? What is a primary key? It's the same as a partition key, maybe, or it is the main house key. It does not apply to NoSQL databases, or it uniquely identifies a row, or maybe it is a column in the partition key. Okay, now everyone has answered it, and time is up. And most of you made it. Primary key uniquely identifies a row. It's not the same as a partition key because primary key includes partition key, but also clustering columns. Those are optional, but those are part of a primary key, so it's not the same. And it's not a column in the partition key because partition key is by itself a column or a set of columns. No, primary key is uniquely identifies a row and includes partition key and clustering columns. So there were some mistakes and maybe, oh, okay, Ravi, Aditya, like I'm afraid that will be much harder now to get to the top three. Maybe some of the leaders will make mistake in the upcoming questions. And Kevin was fastest again. Stop this guy, like really, what's on him? Good. Chat is totally quiet. Everyone is busy with anything. Good. Let's go on. That is question number 6. And answer fast to get more points. What is a partition key then? It's a consecutive number applied to each new record. It's a designated field in your table to partition data. It's an optional table field for optional secondary partitioning. It's the key to partitioning this reality from the next. Time is up. And the right answer, partition key, is a designated field or fields in your table to partition data. It is not a consecutive number applied to each new record. Distributed databases cannot afford consecutive numbers. Then each next insert will require agree for the cluster on what's the number is consecutive. And then it will take in a couple of hours for a huge cluster, right? So no, it's a designated field to your table, partition your data. So, who made a mistake? And who was the... Oh my God. Okay. So, first of all, welcome Adefemian. Then Ravi makes a mistake, and Tabiso makes a mistake. That quite surprisingly gives chance to vote God, who was also fastest this time. Despite that, actually only 59 points difference between third place and fourth place. That means what Tabiso will try to take his revenge over time to overtake vote God again. Hey Kumar, congrats! And Ravi, I'm sorry that happens on our quizzes. I know. Sorry for that. So Kevin and Surafa doing well, and congrats, Vote God. Congrats, Kumar, for joining the leaderboard top 3. And that is going to be question number 7. So answer fast to get more points. Executing select query without the partition key. Recommended way to retrieve data. Right way, if the data was inserted without the partition key, it's a way to full cluster scan. It's illegal and punishable by law. As a NoSQL police officer, I have to say what answer number 4 is totally correct. But yeah, most of you made it. Good. Right. If you don't give a partition key in your query, then therefore your cluster cannot calculate which server to ask. And if you are going to ask, if you have 100 of servers, then we will have to go and ask each server if maybe it has your data. It's like ordering a pizza without giving your full address, just giving the house address, but not giving the room number. That is kinda, it is as stupid as it sounds. I don't know about you guys, but then I order pizza, I give a full address, okay? And so executing select query without a partition key is a very bad practice. It's a way to full cluster scan. Don't do it, be better than that. Those two people who said it's illegal and punishable by law, I love you. You are totally my people. And it's not the right way if data was inserted without a partition key because you cannot insert data without specifying the partition key. It will be out of token range and we will be no server to store it. Okay, so what's going on the leaderboard? Oh, both Kevin and Surav made a mistake. I see, yes, Surav got excited and pushed the wrong button. That's quite a plot twist, but quite surprisingly, those guys made a very good work before, so they didn't. So they still kept their places, both Kevin and Surav. But now there is a real competition because now the difference between first top three places fourth, fifth place, a very, very low difference. Everything can change with the last answer, with the last question. And congrats, constant learner with the fastest answer. Very well done. And Kevin Paulson, congrats with your fourth place, but we are not done. So get ready because we are getting to the last question of the quiz. Ladies and gentlemen, that's question number 8. Last question of this quiz, and our workshop is almost done. So answer fast to get more points. In the data modeling framework, we start modeling with conceptual data model and application workflow, with physical data model, with logical data model, or with copy-paste from Stack Overflow. Stack Overflow is totally a great resource, but can it help you with your data model for your application? I would doubt that. So, great. There are 10 answers and 5 answers are totally correct. We start data modeling with conceptual data model. Remember entity relationship diagram and things, and application workflow. So application workflow diagram, those are important to us. Physical data model comes last after the optimization, and logical data model comes second after conceptual data model and application workflow. So you must be can't wait till the screenshot, right? Let me tell you something. Winners will have their congratulations, you finished first, second, or third place. Please make a screenshot of the screen so we will be able to identify you because Menti is anonymous. So you will be able to send us the screenshot. Don't forget to make a screenshot of the next screen and let me announce the winners. 5 people made the right answers. And Kevin, Suraf, and Vodgot made the right answers, what make them basically unbeatable. Kevin was fastest again, and we congratulate him with the first place. That is a great result. 6,518 points. That is an incredible result. Then Suraf and Vodgot, so Kumar, congrats with your well-deserved first 3 places. Make a screenshots of the screen. You will have to send them to me. Now, if you are on the top 3, there is a very special congratulations with a prize. If you are on the leaderboard or if you are only visited the workshop but didn't join for the quiz, you know what really matters is your knowledge, is your skill. After this workshop, you definitely will know more about how NoSQL databases are working, about one of the most powerful of NoSQL databases, that's for sure. And as a result, you can be a better engineer, better developer, do your job better, and then in the end get better money. That's quite a good price, I would say. A little bit more valuable than the swag we sent today, which is nice, but not a Aston Martin or Mercedes or villa on the Mediterranean, nothing like that. Sorry, Kevin. So thank you for joining. Thank you, Ravi. Thank you, Kumar. Thank you, Kevin. Thank you, everyone. Thank you, Isaac, and all our attendees. It was totally great you joined us. Um, Quick survey to help us. We would love your feedback because we are running workshops regularly. What did you like the most? What should we improve? I will keep this window open so you can feel it even after the workshop. But now let's go to the next final slides. First, okay, that is wrong. Quiz winners, please contact me on LinkedIn by this link. HTTPS. HTTPS datastacks.io/Alex. That will be me, and you will send your screenshot to me. And if you have any questions about certification or academy or other things, ask me on LinkedIn. Now, homework. Introduction to NoSQL databases, this part, very important. Homework link should be in the chat, and it's also in the repo. Homework link in the chat. Do it if you want to get your. Oh, thank you, Artyom. You made it already. Yeah, Nightbot, thank you as well. It's stupid to say thank you to bots, but that's what I do all the time. Good. Now, next thing. Join our Discord community at dtsx.io/discord. You can ask questions about Cassandra, and not only, it is a great developers community what discuss many different topics, and we announce events there, and so on and so forth. Subscribe, make a like and subscribe on YouTube. Usually you ask to like your stream in the beginning when you have the most viewers, but we did it in the end, but still your likes are very valuable. If you want to get next one, subscribe. Our channel is pretty interesting. There are some Cassandra days with in-person trainings and in-person talks from best of Cassandra experts around the world. In Berlin, one we did last week, and they are coming for London, Amsterdam, Santa Clara, Seattle, Houston, Hanoi, Jakarta, and Singapore. Like we are on the real workshop spree or killing or Cassandra Day killing spree, like doing it all the time, you see? And 4 of them will be simultaneously on the same day, replication factor 4. Kinda. So if you are nearby those places, then please join. If you have friends there, then recommend them to attend. I will be leading Cassandra Days in London, Amsterdam, Hanoi, Jakarta, and Singapore. It's going to be a big, big business trip. And my friends will be running them in Santa Clara and Seattle. And Artyom is in person will lead Cassandra Day Houston.
Yes.
Good. So find out more and register at datastacks.com/events. And thank you for attending. That was a great workshop, and thank you for all your questions.
Thank you.
That's so many warm words in the YouTube chat. Thank you, everyone.